an opportunity for you to review graphing rational functions. There's a good bit in this particular unit, and there's a good bit that's new, asymptotes, for instance. So this is an opportunity for you to review how to find asymptotes, holes, identify x and y intercepts, and actually graph a rational function. Let's get started. Now, first off, the domain of a rational function is the set of all real numbers except those that make the denominator 0. So essentially, what you're saying is it's all real numbers except. So here, if I want to find the domain of f of x, well, remember that I have to factor, so I have x plus 1 in the numerator. In the denominator, I need factors of 21 that will add up to 10. Hopefully you know that that's 7 and 3. So x plus 7, x plus 3. Now, what this tells me is that x is an element of real numbers such that x does not equal negative 7, x does not equal negative 3. Otherwise, it's every other number. So that is the domain. This is in step builder notation. It's the easiest way to write it. If you were going to write it in the interval notation, you'd go from negative infinity up to negative 7, from negative 7 up to negative 3, and then from negative 3 to positive infinity. By using the parentheses, you're simply saying everything but this ending point. This would be the preferable way to write it. Next up, asymptotes. An asymptote is a line that a curve approaches but does not reach. Remember, we do have the exception for horizontal and slant on occasion. A vertical asymptote, however, will never be touched or crossed. If x minus a is a factor of the denominator, but not, there's an important word, not a factor of the numerator, then x equals a is a vertical asymptote of the function. So, again, the previous one, we've got x plus 1 in the numerator, x plus 7, x plus 3 in the denominator. My vertical asymptotes, x equals negative 7, x equals negative 3. These are my vertical asymptotes because those are the two things that x can never be for this function to exist. Moving on, a hole in the graph. A hole in the graph of a rational function occurs when the numerator and denominator both contain the same factor. Find the holes, if any, in the function below. Again, we have to factor. So I have x plus 1, x minus 1. In the denominator, I have x plus 1, x minus 2. Notice I have, okay, thank you. I have x plus 1 in the numerator and denominator, which factor. And then they cancel, leaving me with x minus 1 over x minus 2. This means that I have a hole when x is negative 1, because that's what would make this go to 0. And now f of negative 1 in this new equation, negative 1 minus 1, negative 1 minus 2, this is negative 2 over negative 3, which is 2/3. Here is my hole. Now, what about the x equals 2? I have a vertical asymptote at x equals 2. This is a hole. It's not a vertical asymptote, although x can't equal negative 1, because in the original equation, that would cause the original equation or function to be undefined. The simplified function, however, could exist there if it weren't for this. Next up, we have asymptotes, horizontal asymptotes. Remember, with horizontal asymptotes, you have 3 situations. If the degree of the numerator is less than the degree of the denominator, then y equals 0 is the horizontal asymptote. degree of P of X is 1. Degree of Q of X is 2. The degree of P of X is less than the degree of Q of X. Now, if the leading coefficient of the numerator is A and the leading coefficient of the denominator is B and their degrees are equal, notice 2 and 2, then y equals A over B. In this case, y is equal to 1/2. Up here, y is equal to 0. Now, one thing to be very conscious of, you must put P of X and Q of X in standard form. Put them in standard form. Finally, if the degree of the numerator is greater than the degree of the denominator, 2 is greater than what is understood to be 1 here, then no horizontal asymptote exists. If item 1 or item 2, if there's a horizontal asymptote, there won't be a slant. For number 3, you would have to check to see about a slant. How do we find a slant asymptote? If the degree of the numerator is more than the degree of the denominator, okay, is 1 more, then there's a slant. So the degree of P of X, if that's equal to the degree of Q of X plus 1, then you've got a slant asymptote. How do we find it? Well, we have to divide. X plus 3 will go into x squared plus 0x minus 4. This will be x squared plus 3x. Do your subtraction. Minus 3x. X will go into negative 3x minus 3 times. Minus 3x minus 9. Forgot to bring down the minus 4. Go through and subtract. I don't care about the remainder, so I can stop there. Y equals x minus 3 is the slant asymptote. Identifying x-intercepts and y-intercepts, if any. X-intercept is this, you set the numerator equal to 0 and solve for x. So x, comma, 0. Y-intercept, let x equal 0 and solve for y. That's all there is to it. And remember that here's my x-axis, here's my y-axis. This point here is x, comma, 0. This point over here is 0, comma, some y value. Now, I'm going to bring up 6 problems. Here they are. And what you need to do is describe the domain and then graph them. Now realize that problems like number 1 here, okay, this happens to be the reciprocal function. So that one you should be able to do pretty quickly. You want to graph and state the domain for each rational function. Asymptotes should be listed as well as graphed as dashed lines, and you should note any holes. Now, what I've done is right over here, I've set up this little set of things here. And what you should do is make a copy of it. For each one of these 6 problems, you want to answer all of those questions. Okay? So you want to do the domain, the vertical asymptote, the hole or holes if any, horizontal asymptote. Then if there is no horizontal asymptote, is there an oblique asymptote? Fill it in, the x-intercept, y-intercept. And then use your calculator, find some points, and graph them. Okay, go ahead, pause the video, and work on these 6. Okay, here we go, looking at our solutions. You can pause. I'm going to pause briefly on each one. You can then pause to look at it closer. Here Graph and state the domain for each rational function. Asymptotes should be listed as well as graphed as dashed lines. Here's all that information that I had before. And should be able to graph that. Next up, you're doing good. Notice over here, I tell you if there are no holes. I also note that the degree of the numerator equals the degree of the denominator, thus lead coefficient over lead coefficient. X-intercept and Y-intercept. Plug in zeros where appropriate. Here's the third one. Okay. Notice on this one, we do have a hole. Oops, where did we go? We do have a hole. Here's my hole right here. You graph the hole as an open point. No x-intercept, no y-intercept. Notice x cannot be 0, and then y can't be 0. Why can y not be 0? Because I have to set 4x. If I let y equal 0, then 4x has to equal 0, which means x has to equal 0, but it can't. Okay, so there's no x, no y-intercept. The range, y is greater than 0 or y is less than -1. Okay. You should be able to define the domain. You can also define the range on these. The range are all the y values. Okay. For this one, I'm showing you the work. Factor it. Since you have something that cancels, you will have a hole. Okay. If factors cancel, then you have a hole. You could have more than one hole. Notice this is just a line. A linear equation, slope of 1, y-intercept of 1, it simply has a hole. Okay? Next up, whoops, where'd I go? Okay. Should be able to read through this. And again, how did I get the curves? I created an XY table, plugged in a couple of points on the left and on the right side of any vertical asymptote. This is a case where it does cross the x-axis, but then it comes and it keeps getting closer and closer and closer to it again. Finally, the last one that you had. Okay. Here's the function. I'll put it here so you can see it a little bit better. If you have any questions on how to do any of these, bring the problem and the question to your instructor so they can go over it. Okay, no holes because nothing canceled. Vertical asymptote, x cannot equal 1/3. Horizontal asymptote, the degrees of the numerator and denominator are the same, so it's lead coefficient over lead coefficient. Because there's a horizontal asymptote, there's no slant. The x-intercept and the y-intercept just happen to be the same, 0, 0. You can potentially have multiple x-intercepts. There will only ever be one y-intercept. Why? Because these are rational functions, and rational functions must pass the vertical line test. Good review.